All right, so let's start with a one sample t-test analysis in SPSS. So if we think about our case study, essentially we had three cities, city A, city B, and city C, and we had pre-event sales and we had post-event sales. So in other words, our sales before we ran the um, uh, we offered the freebies, our sales before we attended the road shows and so on, and then our sales after those things took place. If we go to our variable view, you can see that there were three variables in this data set that we're using in our example. So our first one is city, and city has been labeled name of city, and it includes our three values, city A, city B, and city C, labeled as 1, 2, and 3. So we press OK on that. We make sure that our measurement is accurate here. Nominal makes sense. A isn't better than B, for example. We're just labeling A as 1, B is 2, and C is 3. The next variable we have is pre-event sales. This is scale. This is actually a ratio data because you can't have less than 0 unit sales. So 0 is our starting point and it ranges up from that. So that is scale measure. And same for post-event sales. So unit sales after the event is measured using scale data as well. So it's important to confirm those, make sure SPSS is going to run the data correctly. Next, we can go into the data view and we can confirm our variables this way as well. Make sure our data makes sense. So here we have city, followed by pre-event and post-event sales. So for example, in city A, remember 1 equals city A, the pre-event sales in this first row were 125 units, and the post-event sales is 129 units. So it went up by 4 units between pre and post-event. If you scroll down, you'll see city changes to 2 and then changes to 3 finally. So we have all three cities represented here. A good first step before you run any of the t-tests that I'll show you in this video is to confirm that your data is normally distributed. An important assumption when doing t-tests is that because they are what we call parametric tests, in other words, they rely strongly on the data being representative of the population, we want to make sure that that is in fact the case. So what I like to do is go into descriptive statistics, frequencies. We can bring our two ratio data points over. You can't do a normal curve on name of city because that's nominal, right? But for these two variables, because they are ratio data, we can check the normality on a curve. So what you can do is go to charts, choose histogram, and show the normal curve on the histogram, and then press continue. If you really want to check the normality, you can also go into statistics and add skewness and kurtosis, and this will give you those between negative 0.5 and positive 0.5 values. So we know that if we're above or below those two values, we might have an issue with skewness or kurtosis. And then we can press continue and OK. So the first thing we'll confirm is that we have no missing values, which is great, and our skewness and kurtosis values here. So as you can see, it does actually go slightly above 0.5 in both cases, before the event and after the event, but it's not very high above that. And in this case, I would still accept it, only to note that this would be something you would indicate as a limitation in the study. So if you do still run the analysis, even despite it going above those cutoff values, you can still do it, but the interpretability of your findings is negatively impacted to an extent. For kurtosis, no issues there. Okay, so we will scroll down to our histograms, and here we can see a fairly standard looking normal curve with a standard deviation of 17.8 2 rounded. And for sales after the event, it is slightly positively skewed, as we saw earlier in that table, but this is still an acceptable curve for us to make a comparison against. So after we've done that, we then can go into Analyze, Compare Means, and this time we're going to choose one sample t-test. And we have to think about, at this point, what is our research question and what are our null and alternate hypotheses. So in a one samples t-test, you are comparing the, in this case, we're comparing the sales after the event with some sort of predetermined average. So in this case, we want to know, for example, is there a difference between our average of 140 units that we typically sell in an average day versus our after event sales? Is there a statistically significant difference between the two? So say, for instance, we know that in an average day, we sell 140 units and we want to compare against that. So let's do that. So let's click on Sales After Event and bring it over to our test variables box. For test value, we're going to put in our comparison average. So in this case, we want to know, how do our sales after the event compare to a test value of 140 units? How do these two numbers compare against one another? Okay. It's always a good idea to go into options and confirm that you have selected a 95% confidence interval. This is essentially saying that you are accepting that out of 100 responses or 100 observations, that you can have up to 5 of them not reflecting the results of the study and still conclude that they are valid and something that you can still reasonably believe that the results that you were looking for were confirmed. In other words, you can reject a null hypothesis if 5% of your responses go against it. Okay, this here is in regard to missing values. Our data set doesn't have any. However, if you did have some missing values, it's important to tell SPSS what you're going to do with them. I strongly encourage you to always select exclude cases analysis by analysis. Another way of wording that is exclude cases pairwise. And the reason being is that when you exclude cases listwise, you are telling SPSS that if that case specifically is missing or a data point is missing for that respondent or that observation, the entire observation itself or that case itself is excluded from the analysis, which can be problematic. In this case, we only have 3 variables. It's not a big deal. And as I said, we don't have any missing values. But when you're working with large data sets with many variables within them, it is important to make sure that you're not unnecessarily excluding invalid responses. And to do that, you exclude cases pairwise or analysis by analysis. And then you'll hit continue. Once we have everything set up, we can hit continue or OK. And this is our output. So here we can confirm a few things. First of all, our N matches with our N from our frequency analysis. So we know that we have 79 respondents, or 79 observations in this case. And here we can also see that our sales after the event was a mean of 151.76. It's important that since we're talking in terms of units sold, that this number is rounded. So we'll round up in this case. So we'll say that we sold an average of 152 units after our event took place. Our standard deviation gives us our data in regard to the distribution of the data around the mean. And our standard error gives us additional information regarding how the standard deviation relates to the square root of our population. So if you take the square root of the population and compare it to the standard deviation, you end up with the standard error mean. And this is important because, as you know, the t-statistic, the formula for that is essentially, and I'll pull it up here, t equals the difference between the sample and the population means divided by the standard deviation, which itself is divided by the square root of the population or of the sample size. Okay, so we'll come back to that in a moment, but first I just want to introduce a few more ideas here. So what essentially you're doing here is you're saying, you know, if we think about our hypotheses, our null hypothesis, if we're saying there is no difference between this mean here, 151.76, and our mean in our that we selected, our sort of standard average of 140. So this is the difference reported here. So the difference between 151.76 and 140 is reported here as 11.759, right? What would happen if you took that difference and divided it by the standard error mean? Well, that is exactly our t-statistic, right? So I will do that here. So let's say we have our sales after event and a mean of 151.76. And then we have our average sales of 140. And the difference is this minus this. And then we want to compare that to the standard deviation of 17.360 and the square root of the population size. So in this case, it is square root of 79. And then the two numbers are divided. You ended up with 1.953, which can be confirmed here. So this result here is our standard error mean. And then it's simply a matter of taking the difference between our two means and dividing that by our standard error mean. And the result is what we call a t-statistic. So this t-statistic on its own, it does tell you how far apart the result in our analysis is from the mean that we selected, but it doesn't tell us the significance. It doesn't tell us if it's a significant difference or not. And the way to do that is to refer back to our one sample test table, looking at sales after event, and moving over to the two-sided p significance. And we always want this number to be less than 0.05. So in this case, we have it less than 0.001. It is a very significant result. So you combine that with your t-statistic to conclude that you will reject the null hypothesis. In other words, there is a significant difference between our after event sales and our selected average sales in a typical day. So this will be typed up and then reported accordingly.